Logical-linguistic model of Ukrainian text by Kryvyi, Sergii, Nataliia, Darchuk, Viktor Sorokin, Taras Shevchenko National University. Aim: to develop an analysis methodology of Ukrainian language texts using two components, linguistic and logical, both of which are based on the formal apparatus of linguistic and logical modeling analysis. The computational grammar AGAT is an integral computational model of Ukrainian, is an example of formal apparatus of procedural knowledge representation. In AGAT, the ontological and the gnoseological aspects complement each other, functioning together. The model, an active text analysis automation, hierarchically solves all necessary tasks analogously to a human linguist, but does so according to the rules of computational grammar. And the grammar comprises two parts, morphology and syntax, as well as semantics as the final stage of text analysis. The scientific novelty. The scientific novelty is in the combination of knowledge from natural language texts and powerful mathematical logic apparatus, which allows representation, analysis, and knowledge extraction from unstructured natural language texts. In Ukraine, there are no similar research studies. Methods. Methods of structural linguistics are used in linguistic analysis models. Distributive analysis, constituency and dependency tree construction, and component analysis. Automatic morphological analysis model uses the distributive method. Automatic syntactic analysis model relies on constituency and dependency trees, and automatic semantic analysis model utilizes component analysis. The logical component. The logical component utilizes the results of formal grammar analysis. Full automation of the logic modeling stage encounters the problem of choosing a formal logic language in which knowledge obtained on the first stage is presented and studied and depends on the complexity of the input text T. This problem is solved in the following way. Usually, a first-order predicate language is chosen for working with knowledge, as it is expressive enough and has well-developed algorithmic tools. This choice is also confirmed by the fact that the selection of higher-order logical languages has a high complexity of the analysis process and insufficiently developed tools for logical inference. Experiment. The stages of computer language analysis are tokenization, segmentation of letter sequences into words and sentences, morphological analysis, part of speech and categorical grammatical information, syntactic analysis, automatic construction of trees of sentence dependencies, the result of which is also a marked tree of subordination, attribution to each pair of words of the type of syntactic connection and syntactic-semantic relation at the level of the morphological way of expression of the owner. Semantic analysis, determining the meaning of individual sentences on their parts. Logic model analysis, i.e., translation of the input text into the language of mathematical logic in order to identify contradictions, illogicalities in the expression of meaning and the possibility of obtaining information relevant to the request from it. Algorithm of logical-linguistic text analysis. Input, initial text T. Output, results of queries to knowledge base of the text T. Method. Algorithm start. Enter the initial text T. Carry out syntactic-semantic analysis of T. Based on the results of the analysis of T, construct a table of codes of classes of text T. Based on the table I of codes, construct a universe B for text T. Give an interpretation of the text of the universe using an information search thesaurus. Carry out logical analysis of the universe. Check the obtained facts for inconsistency. If the facts are not inconsistent, then enter them into the knowledge base and generate answers to queries to this knowledge base. Algorithm end. The stages of logical-linguistic analysis of the text. Stage 1. Morphological analysis of the given text in the order to construct a dictionary of word and word forms for text T and divisions of this set L equals in braces L1, L2, L3, L4 into classes, parts of speech and categorical grammatical characteristics. A lexical analysis is provided with the establishment of deverbatives, adjectives and denominatives. Stage 2. Construction of set of objects D based on the results of automatic syntactic analysis of the text T and Stage 1 results. At this stage, the terms combining several words, anaphoric connections, etc. are found. Stage 3. Comparison of the set of objects D with the data of the information and search thesaurus. Stage 4. Construction of an ontograph based on the set of objects D. Construction of relations R, L, sync classes. L equals, in braces, L1, L2, L3, L4. The ontograph of the text is built on the basis of sentence ontographs by applying conjunction and simplification rules. The dependency graph and the graph with syntactic-semantic relations. On the slide, you can see two graphs. The first one is dependency graph, and the second one is graph with syntactic-semantic relationships. The semantic logical model of the aforementioned sentence constitutes a predicative augmentative structure of the following type. And in this slide, you can see the table with the semantic logical model. Conclusion from the table. All the information contained in the columns of the table is obtained automatically. Columns 3, 4, see figure 1, and 5, 6 are the results of automatic semantic analysis with the assignment of taxon codes according to the synoptic scheme. The predicate structure equals argument 1 plus argument 2 plus argument 3, etc. argument n. The predicate pair формування каналів action бути головним equals argument 1 маркетингова політика plus argument 2 політика розподілу. So, such method of formulating a predicative structure allows to identify the elements of text that can be disregarded as insignificant form for the point of view of meaning, such as вплив майже на, які потім дуже важко, нехай вони будуть помилковими, часто виникають, які погано відбиваються, часто тією чи іншою мірою. The simplification of text occurs through the use of particles, qualitative adverbs, which are specified by a list. In contrast, referential connections which restore the antecedent of the text are important both for the transmission of the text's meaning and as a linking element between the sentences of the text. About the importance of thesaurus. An important part of linguistic processing is the dictionary component. the thesaurus of terms of the subject area. So, marketing of the information search type, where each term is represented in a network, the nodes of which are terms and the arcs are relationships between terms. Automatic comparison of the predicate structure obtained from the text with the terminological network of the thesaurus is the basis for building an ontograph for the above sentences. The ontograph of the text. R1 predicate бути головним. R2 predicate впливати. R3 predicate передбачати. R4 predicate провокувати. R5 predicate бути результатом. Logical analysis of the results of linguistic text processing. The purpose of logical analysis is to verify the consistency and logical compatibility of facts. To perform logical analysis of the results of linguistic syntactic-semantic analysis, it is proposed to use the tools of descriptive logics and ontologies, because the descriptive logic have a reliable algorithmic basis, and the use of ontologies is a direct way to build a knowledge base. The knowledge base accumulates knowledge obtained from the original text, but this knowledge must be consistent, compatible in a logical sense. The results of linguistic analysis of the input text presented in the form of an ontograph of this text can be checked for inconsistency. To do this, it is necessary to interpret the objects of the universe and determine the formal logical language in which the checks of the properties of the acquired knowledge and the generation of consequences that arise from this knowledge will be performed. Currently, the most suitable descriptive logic for performing such tasks as ALC logic in some of its extensions. For this logic, algorithms for generating consistencies and checking the consistency of a set of knowledge represented by formulas of this logic have been developed. Now, let's consider the formal definitions. Example. Let's consider a given subject area and the interpretation of concepts that appear in the text T about the marketing policy of a company. Conclusions. The combination of linguistic, semantic, and syntactic analysis and logic modeling and ontological paradigm allows us to assert that the process of acquiring knowledge and consequences from these inferences can be significantly automated. The significance of the proposed method is seen in the perspective of development as both linguistic and logical analysis of the input text. It is necessary to use the method of automatic construction of an information searching thesaurus of a certain subject. Therefore, the task is to develop as many thesaurus as possible for different fields of science and technology. The projection of a thesaurus onto a specific text of a certain subject will help create a semantic network of the text. Then, the combination of syntactic-semantic relations with logical thesauruses will be the starting point for applying the logical modeling method. This last assessment leads to a certain skepticism in the community of practitioners and particular linguists, programmers, and knowledge base administrators. Upon such criticism and skepticism, the response emerges from the described approach and the possibility of its implementation in practice. Full automation at this stage appears somewhat problematic, as certain details must be clarified by an expert in the field. The expansion of ontology and the knowledge ontological base and the clarification of its concepts related to a specific subject area should be done by the appropriate expert for experts or experts in the subject area. Thank you for attention.